We'll go ahead and get started here. Thank you for joining. Mark Colvin here, account manager with WhereScape. With me, I have Patrick O'Halloran, who is our senior solution architect. Thank you for joining today's webinar, Accelerating BI Insights, Streamlining Data Integration with WhereScape. We'll get started. WhereScape is a full end-to-end data warehouse management solution that creates and uses metadata to automate and fast track your projects. So if you're building out a data warehouse, a data mart, data lakehouse, data vault, any type of data project, the impact we provide is through the data infrastructure automation to help you consistently build a better product faster. WhereScape has been a leader in data warehouse automation for over 20 years. We have over 1,200 customers ranging from small to large organizations utilizing our tools. WhereScape actually started out as a small consulting company creating and building data warehouses around the globe and realized there were a lot of repetitive tasks for each process, creating tables, managing store procedures, etc. So they started packaging and developing tools to automate patterns in development so they can start doing things quicker and faster. And what they found is by using patterns and templates, they could dramatically increase development output because they no longer had to worry about the routine steps that traditionally slows down development. So with WhereScape automation, we talk about an 8 times increase in developer output, but users of the product will tell you if you do something more than 2 to 3 times, you should really consider automating it. And it's this level of automation that helps shrink year-long projects down to months or a 6-month projects down to a couple of weeks. We have 2 products that we'll cover today, or we have 2 products. WhereScape 3D is our enterprise data modeling solution that automates the data modeling side or the design side to meet the business needs. We do this through discovery, profiling, and design automation. WhereScape 3D is designed to quickly turn concepts into prototypes so data modelers and architects have a clear picture of what's been built. You can apply design standards for circuit keys, system keys, or have design standards to help you build out a data vault. So once you have your design, there's bidirectional integration with WhereScape Red, which also uses metadata to manage your physical layer. WhereScape Red is our builder solution that uses templates to generate code for your data warehouse, your data mart, or your data vault. It sits on your target database and creates the objects. It manages your jobs, manages your schedule, has version control, data lineage, everything you need for fast prototyping and agile development. So what's the impact of data automation? The demo that we have set up for you today is on Postgres. Just know WhereScape manages code generation and orchestration for all major platforms, cloud as well as on-prem. So once you start working with WhereScape, you don't need a special skill set to work on the next platform. Just as important, once you start working with WhereScape, anything that you're doing can be recreated for the next platform. So we leverage your metadata to keep track of all the upstream and downstream dependencies so all the objects are in sync throughout the automation process. And so it's this level of automation and detail that helps our customers build a better product that's easier to support. And so now we'll turn it over to Patrick for any questions and to jump into the demonstration.
Hey, thanks, Colin. Let me just quickly change screens here. There we go. There was a Q&A button at the bottom of the screen, so if you have any questions, feel free to type those in. As Colin said, my name is Patrick O'Halloran, and I'm with WhereScape. I'm going to talk about our two tools, both Red, where we use to build individual things, write code, schedule jobs, create documentation, things like that. I'm going to start there, and then I'm going to give you a brief introduction to our design tool. The builder tool is sort of a top-up, bottom-up approach. I refer to it as building a bunch of Legos and then assembling the Legos to create your data warehouse. And data warehouse is kind of I don't want to say archaic, but maybe a legacy term. When I say data warehouse, it could be a data lake, data lakehouse, data vault, data mart, any large data infrastructure, whether you're using it for analysis or AI. The other tool, 3D, which I'll show at the end, is more of a top-down approach. It's where you sketch out what it is you want to do, what you want to build, and then the rules engine will instantiate that. It'll create all the little pieces that need to to make up that design you've created. But again, I'm going to start with the bottom-up approach just to show you how fast we can build things. The idea is that through automation, I can, as Colvin said, I can have a better product, a more consistent product. If I need to add more data quality checks, if I need to make sure that my 12 developers are all generating things the right way, the better product at the end is not only getting it faster, it's getting something that's more usable, where the data is more trustworthy. And one of the huge things in business intelligence and AI is data quality. I think that's going to be a bigger and bigger step, bigger and bigger component of a successful project in the future. So starting with our builder tool over here, we've got data sources on the left, and the data sources could be ODBC connections to a database or to SAP or any place you can create an ODBC connection. Could be JSON files, XML files, CSVs, fixed width, pretty much any kind of file structure you can think of. Could be REST APIs. We could pull data from about anywhere. Over here on the far right, we've got the BI and analytics tools. So this is people using Tableau, Yellowfin, Power BI, Looker, feeding data into an AI engine, whatever it is, exporting data, even Excel spreadsheets. These are the analysts and engineers and scientists who are using the data. What WhereScape does is we build everything in between. So we'll load data from the source system or multiple systems. We'll create what we call a data foundation, which is sort of a permanent historic record of what we've been loading. And we'll create a semantic layer. If you're familiar with a medallion architecture, this would be bronze, this would be silver, and this would be gold. This is also called semantic layer or presentation layer. While we're doing this, we're capturing all the metadata. When you're using WhereScape, you're describing what you want to do, not how you want to do it. It's very, very low code. Instead, our years of experience in working with data warehouses allows us to get the information from you that we need to build the data warehouse, and then we fill in all the details. With that, we can create documentation. I'll show that off. And then we can also schedule jobs to run on a regular basis, which, you can use our scheduler, you can integrate it. A lot of our customers integrate it with their own enterprise schedulers as well. So I'm going to get started. As I said, my data source is going to be a SQL Server database. I'm going to be using the Northwind database as an example, sample database from Microsoft. And all this work here in between the red bars is going to be done in Postgres. As I said, we support about 18 different what we call targets. So whether it's Snowflake or Databricks or Azure Synapse or Redshift or Oracle, whatever it is, we can create our data warehouse in there. And as you watch what I'm doing, you'll see that very little of what I'm doing is actually specific to Postgres. That means if I do need to migrate in the future, I can reuse almost all the work I've done. So I'm going to create a load table, which mimics our source system, gets data into Postgres. I'm going to create a stage table where we do any kind of transforms, hard business rules, soft business rules. I'm going to, just for the sake of time, skip over this entire middle section, and I'm going to go straight to creating a dimension. So let's try all that. Here's my Northwind database. I can browse it. This is, again, just an ODBC connection. I've got all the tables here. I can look at the tables. I can see columns. I can see data types. I can browse the data and see that on there as well. This is what I'm going to be pulling data from. Again, this could be REST APIs, JSON files, XML files, whatever it is. This just happens to be an ODBC connection to a database. Load tables are where we bring data into our target database. So I'm going to create a load table for this. I'll just drag this over and drop it. We've got naming conventions here for prefixes and suffixes. That's all configurable. The schema this is going into, this has been pre-configured. I've got 3 schemas set up, one called load, one called stage, and one called EDW. That's all configurable. And then WhereScape is smart enough to understand that this is going to Postgres from SQL Server. Again, this could be Oracle from a REST API. This could be Databricks from a JSON file. We know all the typecasting, type conversions, things like that. Those are also extensible. If there are types we've missed or you don't like the way we do data type mappings, those are all configurable. Some basic options here and what I can do. Pretty simply, the ones I want to talk about are I'm going to be generating a Python script that's going to actually do the load, pull data from SQL Server and get it into Postgres. If I want to run any SQL beforehand, if I want to do any kind of app post-processing procedures, that's all possible as well. But I'll just do the vanilla thing where I'm going to create this table and create the Python script that loads the table and then runs it. And we're done. So this is everything that WhereScape is doing. We're writing DDL to create a table in Postgres called load customers. If you notice, the data types are different than what we have in SQL Server because nchar 5 doesn't exist in Postgres. we've got Postgres data types here. We're actually going and grabbing metadata if it exists. And we know that in SQL Server, you can have extended attributes that are just metadata about the column. So we went and grabbed all those. Then we created and ran this script that pulled data out of SQL Server and loaded it into Postgres. So what does that script look like? Well, it is 379 lines of Python code. I don't know Python. I can read it. I could probably debug it, but I don't know it. I don't know how in a Python script how to pull data out of SQL Server. I don't know in a Python script how to load data into Postgres, but hey, guess what? All that's taken care of for me. I don't have to worry about any of that. It all works, and it all works the first time. This is fairly straightforward, but as I said, it could be as complicated as parsing a JSON file and getting that into another database. Right, here's my load table. It was just created. It didn't exist a few minutes ago. Here's all the data that's in the load table that mimics what was in my source system. All good so far. So what I'm going to do now is I'm going to create a stage table where I'm going to add transforms. As I said, any kind of data quality checks, conversions, data type conversions, adding calculated columns, any kind of stage table, any kind of transform you're going to do can be done in stage tables. So I set my context here to stage tables. I browse, instead of browsing my source system, I can now browse my data warehouse and refresh this because I've now got a load table here called load customers. I can drag that. Again, same naming conventions, prefixes, suffixes, what schema it's going into, all that is configurable. And I've got options here. I'm just going to rebuild my script for populating my stage table from my load table. And I haven't added any transforms yet. The one thing I will do is I will tell it, here's my business key. That comes in handy later. I'll just say okay. And not terribly exciting, but now I've got a stage table that exists. And I've got data in my stage table that pretty much mimics what was in the load table. Lastly, what I'm going to do is create a dimension and populate my data into the dimension. And then I'll talk about some of the advantages of doing all this. So again, set my context to dimensions. I can refresh this, look at my stage tables. Here's my stage customers. Again, naming conventions, dim underscore customers. And I've got some options here because Kimball created a couple different types of dimensions. Type 1, I know this is type 1, this is type 2, this is type 3. This I think is type 6, but I've never used a type 6 table. I'm going to create a type 2 just because they're fun. They're also a little more difficult in deciding how do you keep historic data. The idea of a type 1 is you've just got one record per grain in the dimension. And if something changes, you just update it. The idea of slowly changing dimension is I can keep track of historic changes. I've got the ability here to add some comments in here. This will show up in the documentation. So I can say, this is tracking online customers. It is. I can put my grain in here and say 1 row per customer. I want to have examples of how to use this table and things like that. That's all in here. I've got the ability to add comments at the column level. Maybe there's a fact table and there's a number, and I want to indicate in the documentation whether it's gallons or liters, whether it's pounds or kilograms or meters or yards or feet. I can add all that in the documentation as well, which comes in very, very handy. All right, I'm going to build my update script that updates my type 2 dimension. I got the business key flowed in from the stage table where I identified it. And if I just click OK, it's going to say, hey, this is a type 2 dimension. You need to tell me what fields you want to track historically. And I can select all of them, but I'll just select all these geographic ones and say, okay, okay. It runs, it populates, and now I've got my dimension here. And if I look at the data, I've got a couple things. I've got my ghost record in case we try and join a fact table to this dimension and the customer ID doesn't exist in the dimension. Instead, we'll connect it to the ghost record just so you can always join to something. We've got our surrogate key here. And then if I scroll over, I can see I've got some metadata here describing the effective start time and effective end time of this specific record, whether it's the current record or not, and then what version it is. So all that's in here. I know people who've spent weeks just trying to figure out how to implement a type 2 dimension. And I was able to quickly go in, start with my source system, create a load table, a stage table, and a dimension. And now let me show you something about transforms. A lot of times data analysts don't know what they want. You don't know what bad data looks like until you see it, or they don't know what the reports they're going to generate until they get an idea what it looks like. one of the real nice things about data automation, the fact that I can make changes so quickly, is I can prototype in front of somebody and just show them, here's what it's going to look like. And that they can use their own tools, because this is a real table in a Postgres database, or again, Databricks, Snowflake, whatever it is. They can use their tools they're familiar with to query this data. And maybe they come back and say, this region here is kind of messing things up. These are null values. Can you put something else in here besides a null value? Sure, I can add a transform. As I said, I can add transforms. I can add calculated columns. I can pretty much do anything here. So I want to add a transform to region. I've got information about this, comments about this. Again, if I wanted to put something on here saying something about what this value is. So what transforms can I add? This is going to boil down to Postgres SQL code. So any expression, SQL expression that's a valid Postgres SQL expression, I can include here. Now I do know that there is I believe a conditional function called coalesce that shows me down here what it is. Basically, you give a list of values and it returns the first non-null value. So I will paste in our source system name, and then if that's null, we're going to return the value unknown. It's right here. And if you're watching closely, that's the first time I've actually typed something. One of the concepts of automation is if I could do things by checking boxes and working that way, I have less of a chance of introducing errors. I have less of a chance of making mistakes, which means testing gets reduced, refactoring gets reduced, rework gets reduced, modifications get reduced, data quality goes way, way up. And as I said at the beginning, the most important foundation of business intelligence and AI is good data you can rely on. All right, so I've added my transform. Let me just refresh this. And if I look at the columns again, I can scroll over and say, hey, here's my transform I just added. Syntax looks okay. All right, I need to whoops, I did that in the wrong spot. I did that on my dimension. I didn't want to do it on my dimension. I wanted to do it on my stage table. So this is an example of me making a mistake during a live demo, but also how fast it is I can make these changes. And as I said, transforms are usually done at the stage table level. So let me remove this. I don't need this anymore. I put it in the wrong spot. I should have cut and pasted, but I didn't. Instead, I'll go to my stage table. That's where I want to add my transform. Go to transforms, go to functions, go to conditional, go to coalesce, paste in my load table name, and put in there. Now I've got it in the right place. It would have worked where I had it before, but best practice is to put all your transforms in the stage tables. All right, I need to recreate that code to rebuild my update procedure. That's all okay. It's rebuilt. I need to execute it. So I can execute my update script. It'll reread the data from the load table. And this time, because I've got the transform, instead of having null values here, we've got the word unknown. I didn't change my dimension at all. All I changed was the data feeding into it. So I can just rerun this update here. And now if I look at the data in my dimension here, display data and sort by customer ID, I can see that it doesn't, it should. There should be multiple values per customer here. And if I scrolled over, the effective start and end dates would be set up correctly for those customers. All right, so that's an example of creating a dimension, type 2 dimension from a system, the idea that I can generate lots and lots of code. If I look here and look at my edit script, this is what's 336 lines of code that's populating the type 2 dimension. It understands that if variables, if values we're tracking change, it needs to insert a new record. If values change that we're not tracking, it can just update the existing records. There's a lot of complicated code here that works the first time, which is nice. Here's a fact table I created earlier. It's joining together facts, orders, order details, and then dimensions to employees and products. We've got a nice feature here that I can look at a track fact diagram and I can see that the fact table is coming from a stage table, which comes from the load table, which comes from the source system. All this is generated automatically. I didn't need to tell it this. This is an artifact of using the product, creating load tables from source systems, creating stage tables from load tables, creating facts and dimensions from stage tables. I can go here, I can create a job that populates this. I can give it some degree of parallelization. I can tell it how often I want to run this job. Exists, so I'll just stick a 2 on the end. It understands the order in which these subtasks need to be done. And as I said, I can have our scheduler run this on a regular basis, or I can have an enterprise scheduler run this on a regular basis and report back success or failure, send out email notifications on success or failure. All right, another nice feature of the metadata is documentation. I can create my documentation. I select a folder. Documentation is created as an HTML file, which can be shared. This opens up in my browser. I've got 2 types of documentation. User documentation, which is meant for the end users. Here's my glossary of all the terms that appear in my data warehouse. And as I said, if I had comments on here, if there was something on, say, price, or I can indicate whether it's in dollars or euros or whatever it is. If it's something else in the volume, I can say whether it's in liters or gallons. I can add those kinds of pieces of information here that really help the analysts. And then here I've got my new dimension I just created. I've got the comments I typed in, as well as any examples or usage I could have put in as well. This is the end user documentation meant for the analysts. I've also got technical documentation that's meant for the developers. It's got a lot more information in here. Again, the same glossary, but under my dimension, I've also got information about what the procedures are, so I can look at the actual code, the Python code that's going to get executed to update this dimension. I've got a trackback diagram in here as well, so I can see, scrolled a little too much. We'll reset this back to 100%. Okay. I can see the dimension came from stage table, came from load, came from customers. All the columns in my dimension came from the stage table. And someone may ask, where did a value come from? Well, in the tool itself, I've got that trackback diagram, but here I can go look at the stage table and I can see, oh, there was a transform that was done on region. I can go back to the load table and see how the state is getting loaded from my source system as well. So this is the builder tool that I wanted to show you called Red. There's a lot of capabilities here, a lot of intelligence built into it, a lot of automation. I was able to create a type 2 dimension, get it up and running in a matter of a few minutes. I was able to create the documentation for it. The nice thing is, if I have a development system, I can regenerate the documentation every morning and put it out on a shared drive. And anyone who's working on that system will have up-to-date documentation. That's the bottom-up approach. The advantage of this, again, are that it's consistent. Whether I do this or you develop this or Colvin develops this, the code's going to look the same because it's all generated from templates. If I don't like what the code is doing, I usually have options in these wizards to change what it's doing. But if I don't like that, we've got all the templates right here. I can modify these templates, copy them, and then modify them. Maybe I need to add some extra functionality. Maybe there's more data validations I need to do. In my scheduler, you saw that I was populating the load table, then the stage table, then the dimension. I can certainly add steps in there if I need to do data validation, if I need to write it to log files. It's a very, very flexible, extensible product. Let me just give you a quick example of the builder tool. Again, not the builder tool, the design tool. The builder tool being bottom up, the design tool being top down. And I've only got a few minutes, so this is going to be a very, very superficial demonstration. I'm going to create just a real quick facts and dimensions here. I've got a source system, same kinds of connections, ODBC connections, JDBC connections, files, REST APIs, all those. I can connect to all those. I've done some profiling here. So I've looked at my source system. I've done this already. This takes a few seconds, but I'm going to skip over it. Where it understands all the relationships between all the objects in my source system. And then what I can do is I can create my star schema. So let's say I'm going to create a new star schema here. Today is June 13th already. I start with a blank slate. Here is my star schema I'm going to create. I'll just delete this Teradata one. I don't need that. But let's go back to my source system. Here's my Northwind database. Let's say I want orders. I'll just drag that over. That's going to be a fact table. I want sum of order details, say product through discount, and I'll add that to my fact table. I want customers as a dimension, and we'll make that a changing dimension like we did in our builder tool. And I will select these same attributes. What else? I want products. That's a good dimension to add here. And I'll add employees as well. Regular type 1 dimension. I didn't do something here. Let me drop this and recreate it. There we go. We're going to make that a regular dimension as well. Oh, I see. I didn't check it. I highlighted it, but I didn't check it. So now I've got my simple star schema. I've got my fact table that's been denormalized with the details. I've got my customers that are joining that fact table. I've got products and employees as well. So I'll move this over here just to give it some room. And I'll grab this and drag this up here as well. Yep, I'm trying to create a relationship there. Zoom out a little bit and just move this up here. It's a little messy. I can clean this up some, but I'm not going to worry about it. The next thing I can do is create my artificial keys, my surrogate keys. That's as simple as running rules. The rules based on what primary keys and foreign keys we have in my source systems, and now understands that dim customers goes to the customer dimension, dim employees goes to the employees dimension, and products is on there as well based on the product ID. From here, I can create load and stage tables, just like I created load and stage tables in the builder tool, add any transforms I need to do. The model conversion rules that create these are incredibly flexible. If I want to add naming standards, if I want to add transforms automatically, as Colvin said, if there's anything I'm doing manually 2 or 3 times, I can create a rule that will do it for me. And the nice thing about having a rules-based product is, again, the consistency. The consistency, and I don't need to remember that if I bring in another source system, oh, that's right, I need to rename cust ID to customer ID, or I need to convert something to uppercase. The rules take care of all that. We're almost out of time, so I'll just speak over this and just say from here, I can create my load and stage tables. As I said, I can then export this into red. It'll automatically bring it into here. It'll create a separate project down here, and all my objects will be in there along with all the DDL to create the objects. Actually, the DDL will be executed. The objects will exist. And then all the scripts, Python scripts needed to migrate data through my system. So I can literally create that fact and dimensions and have it created in Postgres in a matter of 10 minutes. And another nice thing, there's a lot of nice things I keep saying. One feature of this is the last thing I do before I push it into Red, our builder tool, is I say, what's the target? Some of these data types like TGT integer don't exist because we don't know what the target is yet. If I generate this for Postgres, it's going to generate different code than if I generate this for Snowflake. And it's going to create different load scripts for how do I get data out of SQL Server into Postgres, how do I get data into Snowflake, into Databricks, into Google BigQuery, Azure Synapse. Again, the nice thing is all that's taken care of for me. This was a real high-level overview of the builder tool, being able to consistently create products, a data warehouse, data infrastructure, data foundation that you can use for business intelligence, being able to have that trackback diagram as an analyst. Anytime you present anything, one of the first questions you're going to get is, where did this data come from? Do you trust this data? As you've seen through the documentation, through the trackback diagrams and all that, I can very, very quickly tell someone exactly where this is. I ran into someone at a show last week, and for them to do that same kind of effort, which is all written in stored procedures and hand-built code, it would take them 8 hours. They'd have to get the request. They'd have to find the procedures. They'd have to read something that someone wrote 3 years ago and is no longer with the company. It would take a very, very, very long time for them to confidently come back and say, here's where the state is coming from. Here's all the transforms it went through. Here's the multiple source systems it came from. So thank you for your time, your attention. I ran a little bit long, but thank you for your time and attention. As I said, this is the proverbial tip of the iceberg. If you'd like to see more, we'd love to talk with you. Feel free to reach out to us at wherescape.com. There is a request a demo button or contact us button. We'll be glad to talk with you there. Coleman, if you want to throw up your last slide with the contact information, we can wrap this up. And Coleman, you are on mute still, I believe. Well, I'll just bring up the slide and I'll talk over it.
I do appreciate everyone's time. Hopefully you can see my screen.
I just see a WhereScape logo. I don't see the contact information. This is slide 6. I think you need to back up one slide.
Okay,
there it is.
I appreciate everyone's time, and feel free to reach out if we can assist with the demonstration. Thanks so much.